So today me and Kevin are going to teach you guys how to solve problems that involve completing the square as shown. Now, to do these type of problems, you need to know two specific topics, which are how to solve a problem that involves square roots and how to solve a problem that involves a perfect square trinomial as shown on the side right here. Now, in this example right here, you have x minus 5 squared minus 100 is equal to 0. Now, the main goal in these type of problems is to isolate the x to itself. So what you would do here is you would add 100 on both sides. Then to get rid of the square, you would square root the whole problem, and you would get x minus 5 is equal to positive or negative 10. From there, you would just add the 5 on both sides, and your answer would be right here as so. X is equal to 5 plus or minus 10. Now, in this problem right here, to solve a perfect square trinomial, as shown in this example right here, the main goal is to look for what we have in blue, which is x squared minus 6x plus 9, or a perfect square trinomial. From there, what we can do is turn this into a binomial, and from there we know how to do basic algebra, so we would square root to both sides to get x. The goal is to get x by itself. So you get x minus 3 is equal to positive or negative 5. You would add 3 on both sides, and this would be your answer. Now, these are the two main topics that you must know when you want to learn how to complete a square. So when solving these type of problems, the main goal is to solve for a perfect square trinomial. So as we talked about before, you have to know how to solve square roots and how to get a perfect square binomial. Using ax plus bx plus c is equal to 0, as shown right here, is basically the terms that are needed to make to complete the square. So this is derived from from the quadratic formula, and basically what you're supposed to do is divide both of the sides of the equation by a to isolate to isolate x, so that the coefficient of x squared is equal to 1, and from there you work on the problem based on the information that is given.
Hi, so right now we are going to solve this problem by completing the square. Now to do that, you're going to want a perfect square on this side. Now, as you can see, this is not a perfect square. So we are going to take out the 5 here and bring it to this side so that we have an open space here to make a perfect square. So, first, we need to know what is going to go in this empty space. And to do that, we follow this equation, which is x divided by 2 squared. Now, x here is whatever number is in the second term here. So whether it's 8, 12, whatever number goes here. So when you put in the 8 here, you get out 16. Now remember, whatever you do to one side of the equation, you have to do to the other. So when you add 16 here, you add 16 over here too. Whoops. 16. This gives you x squared minus 8x plus 16 equals 11. Now, 8x. Now this is a perfect square. This is not a perfect square, but this is a perfect square. Now this allows you to turn this into x minus 4 squared equals 11. Because we want to find out what x equals. So now we square this side. We square this side because you have to do whatever you do to one side, you have to do to the other side. And this gives you x minus 4 equals 11 squared. Yes, squared. No, to the second root. Alright, whatever. So then you have this here. And because you square rooted this, you have to put a plus or minus sign. And now you bring this over here to isolate the x. And then you add the 4 here. Now you have x equals 4 plus or minus the square root of 11. And now you have solved the problem. And x is equal to this. And that's it. In this example, we will be using the completing the square method to solve this. However, now there is a 3 here in the first term. So we will begin like we did before by adding this 6 to this side. And so now we have 3x squared minus 12x equals 0. Now we will divide this 3 from both sides, which gives us x squared minus 4x, and there is a space here, equals 2. So now we need to find this, and to do that we will use the equation that we used before. So we plug in 4 and we get out 4. And so this is x squared minus 4x plus 4. And remember, we have to add 4 to this side because we added it to this side. So that gives us 6 on here. Now, this turns into x minus 2 squared, when factored, equals 6. And so now we divide this, we square this root, and we do it to that side too, which gives us x minus 2 equals square root of 6. And now we add the 2, cancels this out, and it adds it to here. Now remember, this is plus or minus because we got the square root of it. So the answer is x equals 2 plus or minus the square root of 6. This is the last and third and the hardest problem that we will be solving using this method. Now, to do this, we will start off as always, adding 35 over here, which leaves us with negative 3x squared minus 18x equals 35. Now, we will divide this to further try to isolate the x, which is our end goal. And now we will do it to both sides, which leaves us with x squared. Here there's an 8. X squared plus 6x equals negative 35 over 3. Now we have to find out what goes here, and to do that we will use our equation that we used beforehand. And this, when 6 is plugged into x here, you get out 9. So you plug in the 9, you add the 9, and then you add a 9 over here, because you have to do whatever you do to one side, you do to both sides. And so you get x squared plus 6x plus 9 equals negative 8 over 3. And now this is a perfect square over here, which now allows us to turn this into x plus 3 squared equals negative 8 over 3. Now, we will get the square root of this and the square root of this. Now, as you can see, this is a negative. So that means that here we are going to get a imaginary number. So over here, we have this. And now we subtract a 3, which gives us x equals 3 plus or minus negative 3 plus or minus square root of negative 8 over 3. Now, when you simplify this, you get x equals negative 3 plus or minus 2I square root 6 all over 3. And so this is your final answer, and shows that this method works on anything, even getting you imaginary numbers. Thank you.